Hi, hello, this is your Lucky sir. This topic is of JE mains atomic structure. JE main atomic structure, few questions related to Bohr's model, hydrogen spectrum, photoelectric effect, and de Broglie's concept. See, the element having no neutron in the nucleus of atom is straight question. Hydrogen, no neutrons in the complete periodic table. This is the only element. The specific charge is maximum for E by M. E by M is specific charge. So minimum mass, you see, the minimum mass is noticed in case of hydrogen. So E by M is maximum for hydrogen. The ratio of energy of photons 2000 angstrom and 4000 angstrom. Okay, now energy is inversely proportional to lambda. So E1 by E2 is equals to lambda 2 by lambda 1. Means 4000 by 2000. That is equals to 2. So right option. Light of wavelength lambda falls on metal having work function hc by lambda naught. Photoelectric effect will takes place only if photoelectric effect takes place only when sufficient energy photon strikes the metal surface. So sufficient photon, that means wavelength should be lesser. Wavelength should be lesser because less wavelength means more energy. So this is either less or equal. That's why this is the minimum condition. Correct order of radius of the first orbit of hydrogen, helium plus lithium plus 2 beryllium plus 3 is radius is equal to 0.53 into n square by z. So radius is inversely proportional to z. All are of first orbit only. So it is related to only z inversely proportional. This is the right option. Which of the following is not permissible value of angular momentum of electron in hydrogen atom? nh by 2 pi. If 3h by 2 pi, it is this option. If it is h by 2 pi, this is this option. So it is not possible. So this is your key. If velocity of an electron in first orbit of hydrogen atom is v, what will be the velocity of electron in third orbit of lithium? Velocity is directly proportional to z, inversely proportional to n. So he is asking third orbit. So n is equal to 3. Lithium, z is equal to 3. So it will remain same. With the potential energy minus 3.02, then in which of the following excited level electron is present? When potential energy is minus 3.02, the total energy is half of this. So that will be minus 1.5 electron volts. 1.51 electron volts means that is of second energy level. Second excited. Okay, now second excited means third level. N is equal to 3. So E is equal to minus 13.6 into z square by n square. When n is equal to 3, n square is equal to 9. Minus 13.6 by 9 is equal to minus 1.5. Second excited means third level. Don't confuse with this. The energy of hydrogen atom in ground state is minus 13.6. The energy of the level corresponding to n is equal to 5 is same thing, minus 13.6 into z square. Z square is same by n square. N square is fifth level, so 25. Minus 13.6 by 25 is the energy of hydrogen atom in nth orbit is En. Then energy of helium ion. Okay, now ionized helium atom is helium ion. So the energy is En is equals to minus 13.6 into z square by n square. So helium atomic number is 2, 2 square, 2 square means it is 4. So that is 4En. In the following transition, which statement is correct? See, this is lambda 1, this is first level, this is second level, third level. So if this will become correct if it is plus. So this is wrong option. Lambdas, it will become correct when this is given like this. So this is also wrong option. This is right option. The wavelength of spectral line for an electronic transition is inversely proportional to wavelength is inversely proportional to energy. E is equal to hc by lambda. Number of visible lines when an electron returns from fifth orbit to hydrogen spectrum. Visible lines he is asking. So fifth to ground state means 5 to 1. 5 minus 1 is equal to 4. So 4 plus 3 plus 2 plus 1 total lines. In this is first Lyman series, second Balmer series, third is Paschen series, fourth is Brackett series. Balmer series is visible. So your answer is 3. If an electron, proton and alpha particle are having same momentum, the ratio of wavelength lambda is equal to h by p. When they have same momentum, they must have same wavelength. Very simple question. The energy difference between ground state and first excited state of hydrogen atom is, ground state is minus 13.6 electron volts. First excited state means minus 3.4 electron volts. So difference is 10.2. Regular question. We have done many number of times in class. As n value increases, the energy difference between two successive energy levels decreases. I think you remember this graph. Right? This is 1, 2, 3, 4, 5. I used to give this graph as it is in hydrogen spectrum. Here the gap is more, here the gap is less. Okay. As you can see, just now we were discussing, this gap is 10.2. If you take minus 3.4 minus 1.5, the gap will be 1.9. This is between second and third. This is between 1 and 2. In photoelectric effect, the kinetic energy of ejected electron depends on frequency as well as wavelength. So D, both A and B, this is right option. It won't depend on intensity, only number of electrons depends on intensity, but not kinetic energy. The maximum energy of electron in hydrogen atom is 0 when you are giving 0, when you are giving full energy. For example, minus 13.6 is for hydrogen first level. If you are giving plus 13.6, it will become 0. 0 means it is out of atom, completely out of atom. Which electromagnetic radiations has least energy? Okay, now lowest energy you can say, and that is for radio waves. Lowest energy, it is electromagnetic spectrum based question. Cosmic rays, UV rays, visible rays, then IR rays, like that, radio waves. Which relation shows de Broglie's concept? De Broglie's dual nature says that lambda is equal to h by p, or p is equal to h by lambda. The N2 value for third line in Balmer series. Balmer series means N1 is equal to 2. N2 means add 3 more to this. So that is 5. The energy of incident light photon 6 electron volts, whereas work function is 4. You are giving 6, utilized 4. So remaining is 2. That's kinetic energy. The value of Rydberg constant is 1,09,678 centimeter inverse. If you are taking meter inverse, it will become 10 power 7. So answer is 7. For a single hydrogen atom, the electron when jumps from fourth energy level to ground state, the possible number of spectral lines, 4 to ground state, 4 minus 1. 4 minus 1 is 3. That means 3 plus 2 plus 1. Total number of lines will be 6. When an electron jumps from fifth orbit to X, the colored spectral lines are, then X is colored spectral lines means it is coming to the Balmer. Balmer means it is coming to second level. Okay, so here total number of lines will be 6. Here it will be second. Thank you.